Hello everybody, welcome to One Math Army. My name is Muhammad Akhiasan. I'm your mathematics mentor at this channel, and it's been a while since I've been uploading videos. And let's dive into our session by solving a problem. In this, you're asked which one of the following is an integer. Your time starts now. Okay, now let's find out the answer. Wait a second. I am not really going to divide each kind of big number with these small numbers, am I? So those are when divisibility rules come in, and we can tell whether a number is divisible by a certain number without actually doing division, and this saves a lot of time, and there are a lot of benefits of this too, like in your examination. Now let's go. These are the divisibility rules. In this session I'm going to be discussing the divisibility rules of 2 and 3 with their proofs, and mostly you can find the divisibility rule proof for the number 3. So stay with me and let's find out. Now the divisibility rule for 2 is that if the units digit of any number is even, that is 0, 2, 4, 6, 8, then the number is divisible by 2. So first of all, if a number ends with an even number, then the whole number is even number, right? And it's very simple, like it's too easy. Now let's have a small quick example or example of you. Now we have this number 3748092, and we do not have any thing related to the first 7 digits, right? We only want the units digit, which is 2, hence the number is divisible by 2. And the same with this number ends with 0, so this number is even, it's divisible by 2. So if a number is divisible by 2, it's nothing but it is even. If it's not divisible by 2, then obviously it is an odd number. Now this is the proof. To prove that this divisibility rule, we will take the first 10 whole numbers. So take just the first 10 whole numbers starting from 0 up to 9 and multiply them with 2, and we get a sequence, right? Just observe the units digit of the resulting sequence, and this is the sequence you're going to get: 2, 4, 6, 0, 2, 4, 6, 8, 10, 12, 14, 16 and 18. Now I have multiplied them with 2, right? So they should be they all should be divisible by 2, and they should be even, right? Now if you observe here that the unit digits are 2, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, and they keep coming on and coming on till infinity, right? So even numbers end in 0, 2, 4, 6, 8. So that is our proof, right? So every even number has to end with an even number, and that's what the criteria is, right, over here. Now let's go on to the divisibility rule for 3, which is if the sum of the digits is divisible by 3, then the whole number is divisible by 3. So if I have an example, if I have a number example, say 1, 2, 3, and I have to find whether it is divisible by 3 or not, I just add up the digits, that is 1 plus 2 plus 3, and I get 6, and 6 is divisible by 3, so 1, 2, 3 is divisible by 3. So now let's have an example of that. The first example is 3748092, the same example that we took last time. Now in this, add every digit. We are going to get 3 plus 7 10, 7 plus 4 14, 10 plus 4 14, 14 plus 8 22, 22 plus 9 31, 31 plus 3 34, 34 plus 2 36. Now if you know that 12 times 3 is 36, you can directly write that this is divisible by 3, or you can even simplify it by adding 3 to 6, which we will get 9, and 9 is divisible by 3, so the whole number is divisible by 3. Now this proof you may have not heard anywhere. So I have this number xy here, so this is a one number, this is one 2-digit number over here. Xy is a number, and y is its unit digit, and x is the 10th place. Now I have divided into 3 cases, right? And in this case 1 is where y equals to 1, 2 and 3, and I will tell you how I divided them into 3 cases. On what basis I divided them, I will tell you later. Now first listen. So I have multiplied 3 into y, right? In multiplication, first you have to multiply with the first unit digit, right? So that is 3y. So here I have took y from 1 2 3, so this will not exceed 10, so there is nothing like borrowing. That's the basis that I took to separate them. So if I multiply 3 with this, now no number will exceed 10. But in this case, if I multiply 3 with y, it will exceed 10, but it cannot exceed 20. And if I multiply here, it will exceed 20, but it will not exceed 30. It will never exceed 30, because if you want to exceed 30, then you would have to multiply with 11. Now y cannot be 11, right? There can be two numbers in the unit digit, right? So this is our last case, and you can do similarly in this method for the 3-digit numbers and 4 digits. Now first look at this thing. So I multiplied 3 with y and I get 3y. There's nothing to borrow, so I wrote in 3y in the units digit. The unit digit of this product will be 3y. I'm multiplying the tens digit again with x, which will be 3x. So 3x is the tens digit, 3y is the units digit. I have underlined them to differentiate them. Now we know that this number is divisible by 3, right? If we are multiplying with 3, then we know that this number will be divisible by 3. But if we add the sum of the digits according to the criteria, we add the digits, we get 3x plus 3y is nothing but 3 into x plus y, and it is divisible by 3. As you can see, you are multiplying 3 outside. So if it's divisible by 3, then it means that the criteria is true. First of all, let's assume that the sum of the digits should be divisible by 3. Then after checking this, we can make that assumption true. We can make that a statement. So here we have proved it, but still we have two cases left. And the second case is where y equals to 4 5 6, right? And the number will exceed 10. It will exceed 10. So what I've done is 3 into y. What I'll get is 3 into y, 3y. But we know that y is greater than 3 and less than 7, so we know that 3y will exceed 10. So if it's in regular multiplication, like you are multiplying a number with another number and it exceeds 10, what you will do, you will just carry a 10 over to the tens place and write the remaining number. Basically you are just subtracting 10 and writing the remaining number. So here this is a different case, because if you subtract 10, you will still will remain with another 10. So that is a different case. So here going to subtract a 10, so I'm going to get 3y minus 10. Then 1/10 will be sent over here, right? So 3 times x is 3x, and you have a 10 that you got from here, so that is 3x plus 1. You shouldn't write 3x plus 10, you should write tx plus 1, because this is the 10th place, right? Now, so if I'm subtracting 1/10, how many tens I am subtracting from here? That times I have to add here. So if here I am subtracting 1/10, so I have to add 1 here. I am subtracting 2 tens, so I have to add 2 over here. Just take a basic multiplication problem like 18 times 3, and you will understand that, right? 18 times 3 is an example like this, and 15 times 3 is case 2, and 12 times 3 is case 1, right? Now the sum of the digits again is 3x plus 3y minus 9. I am taking 3 common again. I am going to get this, and it is divisible by 3. The criteria holds again. Now this is the last time, this is the last case over here, where y equals to 7 8 9. That's it, 7 8 9. Now the unit digit over here is 7 8 9. I am multiplying with that 3. Here the number is going to exceed 20, so I am taking 2 tens over there. That means I am subtracting 20 from the units digit, so the unit digit will be 3y minus 20, and the tens digit will be 3x plus 2. Again adding those two terms, I am going to get 3x plus 3y minus 18, which is again divisible by 3, so the criteria holds again. Now there are not any more cases, because the unit digit there is only one number, right, and single digit numbers end at 9. So this is the complete proof for the divisibility rule of 3, and mostly you won't get this proof anywhere. Now subscribe to the channel if you are not on the channel, and hit the notification bell to be updated on every release. Like the video and share it to everyone, because sharing is caring, and I'll meet you again.